What's up, my fellow atoms? I'm back in the SLR with another absolute banger of a question. It's kind of a multiple choice, but you really need to know your stuff. So the question asks, for the reaction of sulfuric acid and sodium hydroxide, the standard enthalpy change of neutralization is negative 62 kilojoules per mole, and the energy from bond making is negative 157 kilojoules per mole. Which of the following statements are true? So the first one, the value of the energy for bond breaking is less than the value of energy for bond making. The standard enthalpy change for neutralization is H2SO4 plus 2NaOH goes to Na2SO4 plus 2H2O. And the last statement is the activation energy is 219 kilojoules per mole. Before we dive into the question, I'd just like to say that this is the type of question that you may get in an entrance exam. So for those of you taking natural sciences or chemical engineering or engineering for that matter at Cambridge or Imperial, so we have the ESAT. These are the types of questions that you're going to get where you really need to know your stuff despite it being multiple choice and you can't just, it's very difficult to guess. So without further ado, let's get into the question, right? So we've been told that the standard enthalpy change of neutralization is negative 62 kilojoules per mole. So which means it's exothermic. So we can immediately draw our reaction profile diagram. Very crudely, it's going to look like this, where these are the reactants, where these are the products. Now, in an actual exam, if you're asked to draw this, don't draw it like this. Put your reactants, put your products, and label it. Okay. So the enthalpy change is negative 62, so it goes down like this. Yes. So immediately we can see that the value for bond breaking is less than the value for energy for bond making. So let's think about the acronym BENDO-MEXO. Yeah. This states that the breaking of the bonds is endothermic and the making of the bonds is exothermic. So if we have it overall as exothermic, this means that more energy is released when you're making bonds than when you're breaking the bonds, which means that this is actually true. Although it's worded badly, the magnitude of the energy is actually less because you need to lose energy, or energy needs to be released to the surroundings because it's exothermic. Then let's actually look at number 3. The activation energy is 219 kilojoules per mole. So we know that the value for bond breaking is this entire bit here, from the top of the peak to the products, and this is negative 157 kilojoules per mole. We know this is delta H, which is negative 67 kilojoules per mole. So in fact, we need to find this, which is the activation energy, so going upwards. This is actually just 157, so taking magnitudes, ignoring the direction because they're all in the same direction, minus 67, which is not equal to 219, because 219 is greater than 157. So we know that number 3 is not true.
Okay, so now we've only got one more to answer, so number 2. The standard enthalpy change for neutralization is this equation H2SO4 plus NaOH, Na2SO4 plus H2O, right? Looks pretty standard, bog standard equation, right? However, we need to be careful, right? So the enthalpy change for neutralization, the definition is the energy required to form 1 mole of water from an acid and an alkali. However, here, this cheeky 2, that's going to lose us our marks. So we know that is false. So it's when it comes to questions like this, it's just applying and really reading carefully and really digging deep and looking into all the little micro details, because it's really easy to send you the wrong direction. That's what they're going to try and do. So it's all about being really thorough in your working and really noticing the small details and knowing what to look out for, because I think over on my course at Hills Road, I've seen about 3 times they've put neutralization question and there's a cheeky 2 there.